Today we have to talk about a few things regarding Python, but we also have to talk about this. I didn't remember to talk about this yesterday, so today probably we'll talk about this and what this means in terms of programming languages, and then we'll talk about Python. All right, in terms of or with respect to these as well. All right, and from yesterday, do you guys have any questions? You guys went and studied something or anything, any kind of questions? Did you guys read about swap space? No? Yes? No? Alright, so do read about this thing and let me know if you like it's something just to know about, and it's good if you read. Alright, so what we'll do is we'll continue where we had left off yesterday, and give me a second. Alright, so before we start with compiler and interpreter and what they are and what they mean in terms of in context of say Python. All right, so when we look at programming languages, or if you remember, so the language of computers is binary. All right, and when we say binary, so yesterday we had talked mainly in terms of data. Let's say I want to store a number, let's say 10, into binary into your computer, and it would turn out to be 1 0 1 0 in binary. All right, so that's about data, how you convert data from maybe decimal to binary. But now there is two things. This is data, and there is a second thing called as instructions. What I mean by this is whenever you write something like 1 plus 2 in computer, there are two things to it. One is this has to be converted to binary, this has to be converted to binary, so it will be 1 base 2 and 1 0 base 2. These two are in binary now, but how do you express the add operation into binary? So that's another thing that has to be considered. So now what happens is this is some logic or some code. This is a very simple example. It can be plus, minus, or maybe even a more complex operation. All right, not an operation exactly. This is an example of an operator. It can be something like do this, or check the value of something. There can be many operations. So these kind of operations or the logic has to be expressed in binary as well. And these are the instructions that I am referring to, and these two are the data. So whenever we talk about programs or programming or code in general, so code is just or a program. Let's say you write some code in Python. It's just a way of expressing or telling your computer to do something. So this is a very small code snippet. It just says add two numbers and give me the result. All right. So all of this has to be converted to binary. So it's not just the numbers or the data has to be converted. Instructions also have to be expressed in binary, because computer cannot understand what is plus. It doesn't know what plus is. Or if you write something like maybe some kind of operation to let's say print something on screen. So print in Python is written something like this. I will print 1 plus 2, let's say. And even if this has to be converted, or this has to be done by your computer system, it has to be converted to binary or expressed in binary. So all that conversion also has to be done by your system. And the process of converting your code from this language, which is a high level language, so is either done by two softwares. One is compiler and one is interpreter. There are two softwares or two tools to do that. So if we look at the different kinds of languages that typically people talk in terms of computers, one is low level, or which is your binary. And then there is assembly, which is your something called as mid level. And then there is a high level language. Ideally, I should have written mid here and assembly in the bracket, but my bad. Then there comes C++, Python, Java, etc., etc. All the modern programming languages are high level languages. All right, but your computer would understand just this binary language. It cannot understand any of these. So initially, when people started writing code, they used to write everything in binary. So they would have to remember that the instruction for add, let's say I say that add is noted by 100101001 something. So they would have to remember these codes, and then they would have to express their code in this format. So that was low level when the computers initially started out. Then they created assembly language, which would look something like this. All right, instructions have to be expressed as some like somewhat easier than binary. You can write things in decimal or maybe hexadecimal, and the operations in simple English, like very short abbreviations, and that was called as assembly. But again, your system doesn't understand assembly, so it used to be converted to binary by a software called as assembler. All right. And then came high-level languages where you could write multiple instructions in a single format. For example, if to write a piece of code, it would require me to write 10 lines of code in assembly. It might require only just 1 line of code in a high-level programming language. Plus, they provide some more easier constructs to work with your code. So when people started writing code in high level, and that had to be converted to binary again, so there were two notions or two ways of doing this thing. One was compiled way, and one was the interpreted way. But this is an overall view of why this compiler, interpreter, or assembler exists. Data conversion to binary is one thing, but conversion of code to binary has to be done by a tool, because your computer just understands instructions which are in this format. And when you write code in a high-level language, it's just a convenience over binary language. Actually, everything will run binary, and you cannot do anything in high-level language. So we need a software which can understand high-level language and translate it to binary so that your computer understands, and these two options are compiler and interpreter. All right. This is a basic idea about why there is a need of these two software, because everything's going to run in binary. Cool. And if you notice, sometimes when you download softwares, all right, when you download softwares, they're often, in case of Windows, there is a file called as .exe. You would notice this thing maybe sometimes. And when you get this exe, so typically you're on Windows systems, when you have a piece of code and you convert it to binary, you get a file called as .exe or executable. Executable means you can directly run it on your operating system, and your system will understand what needs to be done. You don't need to do conversion from high level or any language to binary. It's already pretty much containing everything in the form of binary. That's called as an exe or an executable file. All right. So what happens is when you are writing code, okay, I'll talk in terms of compiler and interpreter specifically now. Let's stop this conversion part in binary. Will come back to it. But let's take a use case. All right. Let's say you bought a bicycle and you bought it online. What they do is they ship you a box, all right, which contains your bicycle. Cool. And okay, I don't want to draw it. Cool. There's a bicycle, all right. And now what you need to do is you need to assemble that bicycle yourself. All right, they have packaged that thing into a box, and this thing contains a manual or a set of instructions on how to assemble it. All right. Now the thing is, let's say you talk or you just understand English. All right, let's assume that, and you have to do this assembly yourself. Cool. Or maybe you don't want to do this assembly yourself. You hire a person or maybe a mechanic. All right, and they have to do this assembling of the bicycle. But the instructions are not in English, and this mechanic, let's say, understands English. Cool. This guy talks only English or understands, or that person can read only the English language. Cool. Now, let's say these instructions are in some other language. It's not in English. Let's say this instruction is in, let's say, what? Let's say German. Or do I write? Say GE. Let's call it for GE. It's in German. Now the thing is, how does this guy understand these instructions? And let's say there is no other way of assembling this bicycle apart from understanding these instructions. Now, what you can do is, let's say you are a person, all right, and you already know German. Cool. Because you have ordered it and you know that the instructions are in German, but this mechanic understands English. So what you do is you call this person, all right, and you start reading out the instructions. And as you read, the person assembles the bicycle, and at the end of it, you have a working bicycle. Something cool. All right. And now you have it. But in this process, what you did was you would read one instruction or one instruction mentioned in the manual, speak out to that person, then the second instruction, speak out to that person, third instruction, speak out to that person, and as you speak, they do the job. All right. Same thing can be done by your computer. You have a program in a high level language, let's say in Python. All right. And your computer understands just 0, 1, 0. All right. Now there is somewhere in the middle who reads a line, all right, one line at a time, converts it to binary, and then gives it to your computer so that it can understand and execute that step. All right, this is one way. Now what happens is, once you're done with all the instructions, at the end your bicycle is assembled. Same way, when you are done with all the instructions, when this thing is done with all the instructions, at the end it has done the job that was written, or what program that you had written in Python, whatever it intended to do, it is done. Cool. Now let's say you buy the same bicycle again. All right, fine, maybe for your family or for your friend. Now again the instructions are in German, and you want the mechanic to assemble it again, and let's say that mechanic doesn't have memory of how to assemble the same bicycle again. Now what you would need to do is you would need to read out the same instructions again to the mechanic, and then the mechanic would be able to assemble it again. And each time you want a new bicycle to be assembled, you'll have to translate the instructions again and speak out to them. All right. This kind of way is called as interpretation. Why? Because you're translating thing one at a time. All right. There is another way of doing this thing. What you do is you take this manual, all right, and which is in German, and you go and you write it down on another piece of paper, and you write it in English. All right. And now you hand it over to the mechanic. Now what they do is they are able to read the instructions, and they're able to assemble this bicycle. Now let's say you got the same bicycle again. Now the mechanic needs to assemble it again. Since you have written the instructions in the form of English somewhere, now you can just hand out the instructions, and you don't need to do the conversion or translation again. And you can reuse this manual till the time your bicycle is same. If your bicycle changes, you will anyways need to rewrite the instructions and then give it to him. But if the bicycle stays the same, you don't need to rewrite this thing. And the same thing is done by languages like C or C++, where they pass down your code to something called as a compiler. And this thing converts it to binary. And then this goes to your CPU and gets executed. All right. And now if you need to rerun your program, you don't need to do the compilation again and again. It's just one time thing. Whereas in interpretation, it has to be repeated each time you want to execute your code on your system. All right. So now this is the difference between interpretation and compilation. Interpretation is like you take your piece of code, when you want to execute, you convert it to binary, run it, then you convert the next instruction to binary, run it, run it, run it. You keep on doing till the time your program is complete, or maybe it crashes in the middle. Let's say you write a program of 10 lines, there is an error in line number 5 and your program crashes, and then it would stop. Whereas in case of binary, it just first converts everything to in case of compiler, it first converts everything to binary. Once that is done, then your system will start executing your code, and no translation happens when your system is executing it. All right. So this is compiled versus interpreted. Now to summarize this thing somewhere, and we'll say that compiled is convert to binary once and execute any number of times. All right. Whereas in case of interpreted, it is like read a step, convert to binary, then execute, repeat till done. All right. Is the difference right now clear to you guys between compilation versus interpretation? Is that clear? What happens and what's the difference? Exactly. There are certain more elements to it, but on a high level, this is the major thing that varies between the two. All right. This is clear, guys. If you have any doubts, let me know. Now, I think some of you guys would have in the chat. Some of you guys would have studied about compiler versus interpreter, maybe in college or school. Can you guys tell me what's the difference between the two from what you have studied? Maybe I missed out something. I need to clarify that. That's why I'm asking. Did you guys study compiler versus interpreter? I studied, I remember, multiple times. What's your notion of compiler and interpreter? If you guys remember. Guys, are you there? Oh.
Sorry, I didn't study any of this before.
No,
So
for you, that's fine.
I cannot answer you.
My question
Yeah.
is for Lalit, Pratiksha, and Vedant.
Sure.
This was it clear to you though? This all thing I explained.
Yeah, it's very clear. It's
All
very
right.
simple to understand. Yeah. Just wondering, right? If that's the case, does it mean that Python it has to go through interpreter and is there an option for it to go through compiler as well? Or is it
For
the fixed
Python,
stuff? Yeah.
there is a hybrid approach that Python takes. Why it takes, we'll talk about it based on which is better, compiler and interpreter. Both of them they have their good and bad, and
Mm.
there is a difference between the two. And Python uses a hybrid approach for that reason. To and many languages use this hybrid approach, not just Python,
I
to
see.
get the benefit of both sides, compiler and interpreter. So it uses both.
I see. Sure. Thanks.
Yeah. So I think all of you guys are maybe you're turned on the system and gone away. Not sure. All right, I'll continue then. Or maybe slept. All right. So now let's come to compiler versus interpreter in terms of advantage. Which one do you think is better than the other? What do you think? Just remember one thing, in case of compiled languages, the idea is once you convert it to binary, it doesn't have to be converted again. Whereas in case of interpreted, it has to be converted each time, and conversion from high level language to binary will also take time. All right. So typically in computer systems, or typically in programming languages, compiled languages are faster than your interpreted languages. These are slower. All right. But interpreted languages have something called as JIT, just in time JIT compiler or interpreter, something they have, I don't remember the exact thing. And what this component can do is, see, when you're writing code and in a piece of code, there can be a lot of branches in code. For example, you might say that get the current date, and if this is Monday, then do something. If this is Saturday, then do something. If this is neither of both, then do something else. All right. So when you write this kind of logic, so what happens is certain parts of your code execute multiple times versus certain parts of your code don't execute at all, maybe. All right. So what this JIT or these kind of systems they do for interpreted languages is they're able to optimize that particular piece of code that is being executed multiple times, much better than compiler. Why? Because compiler is done before your program starts executing and it doesn't know anything that what will happen at runtime. Whereas your interpreter works when your program has started executing because it is converting a piece of code and then it is executing. So it knows very well what is happening at runtime or which parts of code are being utilized more. All right. So this is one advantage of interpreted languages. Cool. The other thing is like this is a good thing for compiled and a bad thing for interpreted languages, but there are other benefits of interpreted languages which are not available in compiled languages. All right. And yeah, that's one thing. Another thing is like platform independence. So what happens is when you have a compiled piece of code, you convert it to binary and then distribute it to people. But when you convert it to binary, you typically convert it to binary for your specific system on which you have done the compilation process. All right. Now to distribute it to different people, you need to maybe compile on their system or maybe compile individual binaries for their system and store it somewhere. And for each system, people will have to decide what kind of binary they wish to download so that it will run perfectly fine on their system. Whereas in case of interpreted languages, what you do is you have to install this software called as that particular language's interpreter on your system. Once you do it, you can give the same piece of code to everyone, and then they are able to run that piece of code, and you don't have to write specific code for different platforms in like most of the cases. All right, so that's one benefit of interpreted languages apart from this thing. All right, there is one more advantage of compile. It just came to my mind and then it got lost, but I think this is pretty much the idea. So both of the languages have their good side and bad side. All right, but what happens is typically if you go or read about Python, or when we look at this thing, if I look at CMD or I open this terminal, when I say I type Python, this thing opens something called as the Python interpreter or Python interactive shell. All right, so this is opening the Python interpreter, and this is actually interpreter. Fine, it's literally the interpreter. That's correct. But is Python a compiled or an interpreted language? If that question comes in, so you can clearly say that Python is both. It's both compiled and interpreted. What happens is in these kind of languages like Python and Java also comes into the same category of languages. All right. So what these languages do is they initially take your Python code. Let's say there is a piece of Python code. What they would do is they would run an interpreter on this code and convert it to something called as a bytecode. And this bytecode is not binary language. It's something in the middle, something similar to assembly. It's not kind of that thing, but it is dependent on that specific language. Sorry, I missed this part. This is not your interpreter, my bad. So they run a compiler in the first step and convert it to something called as bytecode. Once you have this bytecode, then when you actually execute the program, they convert this bytecode or interpret this bytecode and run it on your system. All right. And this happens at runtime. So when you write a Python script, so first it will get compiled to bytecode. Once you have the bytecode, when it starts executing the code, it will actually interpret the bytecode into binary and then start executing this thing. So this gives you the benefit of both the things in Python, both compilation and interpretation. And that's why Python uses a hybrid model. It's not just compiled or interpreted, but if typically some people talk about Python, they say that Python is a interpreted language because we are using the interpreter all the times. All right, and it is actually interpreted. That's not wrong as well, but it is also compiled. It first converts the code to bytecode and then converts it to and then starts interpreting it. All right, but this compilation step or this bytecode doesn't happen all the time. It happens only in cases where when you are running code in the form of scripts, and those scripts also have a number of modules. So it happens only in those kind of cases. It doesn't happen all the time. I'll show you when we come to that exactly when this is happening and when you will find the generated bytecode files, but it doesn't happen all the time. For example, when I'm running this code, it will probably internally generate bytecode, but it doesn't get saved anywhere. All right. And anyways, it is getting interpreted over. So when I write 1 + 1, it's going to give me 3. So actually your system is converting, doing everything and running it and then getting the output and then printing it or dumping it on your screen. All right. But the idea is that Python is a hybrid language. It uses both compilation and interpretation. Is that clear? Remember that thing, guys.
Yes.
Sometimes people may ask this in interviews, or like not in like just casually they may ask you about it, and you should know. Fine. So Python is both compiled and interpreted, and that comes to the end of compilation and interpretation and all low-level stuff. Maybe we will talk in future about how the storage of specific data type called as arrays or list in Python works in terms of memory, but that's not something we'll discuss right now. All right, now it's time for code. Let's go to our code repo. All right, so this was your code repo. And do you guys remember how to open Jupyter Notebook? If not, I'm going to open like this. And let's start with some kind of code. And I need one more thing. Let's see if this is the correct one. Yeah. All right. So you guys know how to open the interpreter and open this Jupyter Notebook. If you have any kind of issues opening these things, let me know. I'll help you out with that. All right. So let's start with Python now. So we had already discussed about tools and etc. In our first session, what tool to use and what do they do and which version of Python to use. I haven't shown you how to use Notepad++ and terminal to run the code. That will come up later. Git and GitHub will start discussing probably on the weekend or over the next week. And IDE, if you want, you guys can go and install this software Pycharm on your system. I think you should install and give it a shot. All right. Once we start writing code, probably you can try writing code sometimes with Pycharm and sometimes with Jupyter and sometimes with Notepad++. And you should know a combination of both. And when installing Pycharm, you can go to your platform and download this community edition if you don't already know. So community is like a free version, and professional or the pro or enterprise editions are typically paid. So they give you a free trial as it mentions over here, but they are not completely free. So you can use this community edition, which should be good enough for your typical use case. All right. And coming to the next thing, what is Python? Python is a programming language. And you can see I've already written Python follows Python is an interpreted language, but it follows a hybrid model of compilation and interpretation to to improve performance. And there are two more terms over here. Python is dynamically typed and case sensitive. We'll come back to that thing. And what else? I think this thing contains mostly about your Jupyter Notebook and running Python code and interpreter and stuff. And this thing talks about your compilation versus interpretation. This is, I think, what I've already discussed. All right, platform independence and performance. Compiled is faster, interpreted is platform independent, and this is the way they work. If you guys want to read it out, let me know. Otherwise, I'll move to the next step. Yeah, all right. So this is something about Anaconda. And did I tell you anything about C Python or what is C Python? No, I don't think I. Tom, are you saying something? You can just hear some static noise. Thing is. Okay, let me know if you guys have any questions. So, what is C Python and are there any different kinds of Python? So the answer is yes, there are different kinds of Python. All right. So Python as a programming language, when you write a piece of Python code and you run it on the interpreter, what is interpreter? Interpreter itself is a software, but it was written by the code of interpreter would be written by someone, or the implementation of Python programming language which runs your Python code would be written by someone in the form of code, which does everything, reads your code, converts it to your binary, executes it, takes care of everything. That's all. That's all a piece of code. All right. And now that code can also be written in certain programming language. Why? Because initially when Python would have started out, there would be no Python. Someone would have to write a software for converting your Python or building the Python interpreter, all right, which can convert Python to binary and execute it. So the implementation of Python was initially done. I don't know what the person did, but the one which we download now from python.org and which comes with Anaconda, that's called a C Python. Why it is called a C Python? The reason is that original source code or the source code of that interpreter itself is written in the C programming language. That's why it's called as C Python. And there are other implementations also. For example, I mentioned Jython, PyPy. So Jython is written in Java, I think. PyPy uses something else, I think Microsoft's .NET or something like that. I'm not sure of it. But there are different implementations of Python interpreter or the Python language itself. All right. But the one you download from python.org is C Python, and C Python was written in C programming language. And I think I was showing you on GitHub some in the initial part when I was telling Python is open source, that the source code was written in C. They were all hold on, Python GitHub. Yeah, this is the one. So if we go over here, you can see that name of this repository itself is C Python. So the name of the account or the entire project is Python. And under that, they have put this thing, C Python repository, which is the implementation of Python. And if you'd go to the source code of this thing, and the source code should be present inside two folders. One should be include and one should be Python. All right. And you can see that the files have an extension of .c, and they would be written in the C programming language. And the first file is Python and -ast. AST is abstract syntax tree. I don't know if you guys understand, but it's a huge file. You can see the size of the scroll bar is very small, and it even takes time for my browser to load the page as I scroll through it. All right, it's literally huge. And there is a lot of code written over here. But this is written in C programming language, and that's why the name C Python. Fine. So it means the implementation that you are using is written in C, but does it make a difference whether your interpreter or your language's implementation is in C or Java or something else? So the idea is, yes, it does matter. Why? Because what happens is programming languages have something or can have something called as bindings. What bindings allow you to do is they allow you to use code written in other programming languages to be integrated or used along with your current programming language. So since C Python is written in C, you can easily use C or C++ kind of bindings with Python, or you can use code written in C or C++ with Python very easily, or libraries which use C or C++ with Python very easily. And what happens is your C and C++ are compiled languages, all right? And if you write something in those languages, it's mostly going to be running very fast as compared to your native Python code. So what happens is a lot of your libraries, specifically two of your data science libraries, I should say NumPy specifically, that NumPy is written in your C programming language, or it uses C programming language to make operations or things faster. Because if you are going to operate on data using just Python, it's going to be very slow. So that's why what they wrote is they wrote a wrapper over a C implementation, and that implementation you can import or use in Python, and it performs much better if it was natively written in Python. So that's the advantage. Similarly, Jython would be able to integrate with or use Java based things with it. I have never used these other two. Till now I've been working just with C Python. So these are for very specific use cases. Very few people might be working on them, but the idea is that you should stick mainly to C Python. Don't worry about other implementations. And yeah, that's pretty much about it. But because your Jython would allow you to use Java kind of code, or maybe jar files that are there in Java with or use it in Jython, but C Python might not allow you to do that. All right. Another thing is, since this is the official release of Python, so if any new feature gets implemented, it's going to come up over here first, or it is going to stick to the standard the most. This will be the actual standard for Python programming language. And since they have to, the other people who are providing these options, they have to implement the features that are released in C Python themselves. So they will always run behind the original C Python or the Python implementation, which you download from python.org. All right. So you don't need to worry about it, but just remember there is C Python that you're using, and you can use C related code inside it directly. All right. So this is another thing. It's C Python. Fine. And is there anything else that I should talk about right now? So probably if you want to look up over here, you can read about this thing. Another thing is gradually, I think you should start looking at open source projects in Python, maybe not now, gradually as you learn about things. So because if you look at this, all this stuff, maybe I don't know if you get what all these files and folders mean, but these kind of things may make some kind of sense for me because I've been seeing this kind of structure for since a long time. Probably you guys would have also seen sometime, depending on your profile or what you are doing right now. For example, what does setup.py mean? Just by looking at the name, I know what does that mean because this is a special file for Python. Same way, what might install.sh do? Just by name, I can guess it. It might do something else, but I can guess what it might do. Same way, what does makefile mean? What does readme mean? What does license mean? What does code of conduct mean? What does this file mean? What does this file mean? There are a lot of files. I can just guess what they might be doing by looking at the names. Same way, these folders, what they might contain, I can guess by their names. For example, when I wanted to look at the source code of Python, I went to the Python folder and I showed you the thing. And I even know what does the include folder mean because I've studied C++ kind of thing. And what these might do, what this folder does, why does it start with dot? All that will come as you keep on gradually looking at stuff. And you will just learn by looking at things. When you'll use these things, you will get to know, okay, this thing means this. So right now, if things go completely above your head, like what kind of list is this, this is completely new to you, gradually as you keep working with this thing, they will become very easy for you. All right, but yeah, as you go through this course and through your work and everything, try to look at other people's code because that's a very good way of learning anything. Look at what other people have written, and by reading that, you will learn much more than writing yourself sometimes. Sometimes, I don't mean to say all times, but sometimes it does help you learn in a different. All right, so this is about your Python programming language. Okay, a bit. Okay. Now coming back to this thing, and let's start with code now. So start with something like, sorry, not Python, print. It's a 1+2. All right. Okay, it says kernel error. Probably the kernel has crashed. Okay, there is still a kernel error. Why? So this kernel is having issues. And where does that happen? So this thing is not working. I think I need to reinstall Anaconda in my system. And yeah, so I guess I won't be able to show this thing to you guys over here right now. So I'll open my another Jupyter Notebook. Let's say, I'll start here. If you guys are interested, so this thing is Jupyter Hub. All right. So right now, when I opened Jupyter Notebook, it was running on my local server system on my computer. So this thing is my own personal Jupyter installation, which is running on a AWS server. It's not running on my local actually. All right. So I can access it from anywhere, and it keeps on running till the time the service is working properly. It will just keep on running. So I'll show you over here what's happening. So I can use it the same way like I had done, like I was doing on my local Jupyter Notebook, but it will be somewhat slower because all that I do is going to go to the server, run over there, and then give me the output. So it can be a bit slow, all right, in terms of execution, but I'm able to access it everywhere. If you guys are interested, probably later after your course is halfway through and you want to understand about how to build your own deployment, it's not very useful from a data science perspective, but if you're interested, I can let you know or I can help you out. All right. But the idea is about Python. We talk about it. So this is one piece of code, which I say print 1+2, and it gives me the answer as C. Over there, you can also write something like hello from Python, and this thing would work and it would print whatever you're typing over there. All right. Just go ahead and try this out on your system. If this is already something that you know, that's fine. If you're new to Python, then just go ahead and try this out on your system. Just in your Jupyter Notebook, in one cell, type print, and in double quotes type any kind of text that you want. And once you run it, the shortcut for running is Control Enter. I'll tell you again, or Shift Enter if you want to move to the next cell, and it should give you whatever you have typed in the double quotes. All right, and the name is intuitive. The name is print, so it will print this thing out. All right, I'll guess everyone is done by this thing, and let's come to this thing. So probably I'll share this PPT with you gradually over time, not right now or not today, but as we go, I'll share it with you because this thing has some kind of shortcuts and everything that I typically use or I have already explained. So if you want to refer back to things, it will be useful for you guys. All right. And we'll come back to this thing in a bit. So probably this is the easiest way to run your code. You just open a Jupyter Notebook and type your code and you just execute it. The same thing you can do in an interpreter also. You open an interpreter and you say print bracket, let's say ABCD. Once you do that and hit enter, it prints whatever you have typed over there. All right. If you do something like this, ABCD without just the print, all right, even then it prints it, but it prints in a different way. All right. And there is a difference when you run things on interpreter versus from a script. Even if I type something over here, it will just echo it back the same way it shows up on the interpreter. All right, it will do it the same way. But the benefit of Jupyter Notebook is that you can put multiple lines of code inside a single cell and execute them together. Whereas in an interpreter, you have to type each line and then you have to hit enter to execute it. You cannot write a bunch of statements or a bunch of lines of code and execute them together. Whereas in your Jupyter Notebook, you can do that. But essentially, when you are using your Jupyter Notebook, it is connected to an interpreter behind the scenes. It doesn't show you this black terminal or anything, but behind the scenes, this is connected to an interpreter and it is running the code in an interpreter. So it is going to work exactly like how your this interactive shell or interpreter session works. The only difference is it provides you a better interface and it allows you to do a lot of stuff directly. And in your interpreter, once you close this, it's gone. Whereas a Jupyter Notebook is something that you can save and you can open it again and rerun that thing. All right. So otherwise, this is actually running your code behind the scenes in an interpreter. So the outcome would be similar to what happens when you do this in an interpreter. Remember this thing, because things will change when we start running the code or doing things from a script. All right. Is this clear to everyone? If this is clear, I want you guys to do one thing. I guess everyone is using Windows, so I want you guys to install this software called as Notepad++. All right, just go to this website Notepad++ and go to the latest release and just download it. And don't worry if you are downloading a 32-bit system for x86 architecture, because 32-bit can run on 64-bit, but 64 things cannot run on 32. So it will anyways run on your system. So you can download this and install it and let me know once you're done, guys. We are going to try it out right now. Cool. So I'll paste this link on your Etherpad. So if you want, you can open it from there. And I'll also ping this link on your chat. All right. Do this thing right now if you don't have it already. Let me know once you guys are done. Dilip, Jin, and Pratiksha, Vedant.
I won't be able to
Mm-hmm.
install it now, but I'll do it after today because I'm currently using my company laptop.
Okay,
Yeah.
all right. Cool, no issues. All right. What about you guys? Are you there? First tell me that.
It's already installed.
Already installed? All right, great. And do you know how to use this thing to run code for Python?
No, I
All
don't.
right, I'll show you that how to do. Pratiksha and Dilip, are you guys there? You can ping on
Yes,
chat also.
yes, I'm here.
Okay, cool. Fine. So let's do one thing now. Once you've installed this Notepad++, or if you haven't installed, you can try it later. So what you do is, you just say you open Notepad++. I don't know what files it will open. All right. Cool. So let's come to a new file. So this thing itself has some shortcuts. If you press Control N, it will open a new file and all that stuff. Fine. And you also have an option of folder as workspace. For example, what I'll do is I'll say open folder as Workspace. I'll go to this file menu and I'll say open folder as Workspace. So once it goes over here, let's go to desktop and let's go to folder, and then I'll go to this folder and I'll select this folder, and it shows me the entire structure on the left hand side. Cool. And what I can do is I can go over here in the side the code, I can right click and do some things over here. For example, specifically you'll be finding these two options very useful: Explorer here and CMD here. All right. So what I'm going to do is I'm going to, let's say, open some file over here. Let's say this gitignore. You can see that it contains some text, and I open a new file and I just type over there print bracket hello from, let's say, Python script, any kind of text that you want to write over there. All right, or probably you can try it with me in parallel. Let me know if you want me to pause and show you some step again. And then when I say Control S means to save. I'll actually create a folder for scripts. I'll call it as what new folder. Not a folder for scripts. Let's create a folder for today's session. Let's say this is S011. We are in the initial phases of things, so I'll say 0112021 underscore 09 underscore 16. And why I'm putting the dates in reverse order, because if I put in reverse order, it will keep sorted, or when you say it is sort by name while displaying it, it will come in the order in which the sessions have gone. All right. So year would be first, then your month, and then your day. So it comes in sorted order. And S01 means it's like the first session. It's not the first session actually, but it's like a intro thing. So I'm calling it as 01. And the third one means over here that this is the second or something like that. You'll gradually get it. Don't get confused by the names right now. All right. So over here, what I'll go is you will go to this file name option and I'll say f1.py, let's say. All right. And remember one thing, whenever you're writing Python scripts, your file extensions should be ending with .py. You don't need to change the extension from here. For example, it has different options of selecting the extension. For example, you can find Python also over here. If you scroll down, you can see that there is an option for saying Python file. And once you do that, it automatically removes your .py from there. You don't need to type it. But if you just leave everything as it is, you don't want to change it, you leave it as normal text file, and you just put .py, Notepad++ will automatically recognize that this is a Python script, and it will save it directly. All right. Did it save? Yeah, it's saved. And whenever some file is saved, it will show up as blue over here. And I'll show you why it is important to notice whether it's blue or red. Sometimes we make mistakes. Even I make that same mistake again and again. So that's what I'm saying. Now, once you have saved this file, if I right click on top of this file and I say open containing folder in CMD, once you do this, you see that this terminal has opened up. All right. And it is actually inside the folder where this file is present, because I saved it inside this folder. And now if I say python space f1.py, it executes the code and dumps or shows me the output on my screen. So this is the way how you can run your Python code from a script, or you can run a Python script using any kind of editor and a terminal, or from the command line. All right, this is one of the ways of doing this. You can also use Pycharm for doing all this stuff. Over there, you won't have to open a terminal, and you can do directly write the code over there and also run it from there. But if you want to do it with an editor and a terminal, this is the way of doing it. And you can use any kind of editor, not just Notepad++. It's just one thing which I'm showing to you. And just try it out on your system quick, right now. Let me know if you face any issues or you want me to show you any step again. And just try it out right now. Create a Python script, run it from the interpreter, or sorry, from the terminal. And the format is python space script name.py. And actually do one thing. If you're doing anything on your system, just leave it or stop. I'll show you one more way of doing it. So if you go to this folder where your code is present, so I'll go to this folder, and this is the folder which contains my f1.py. You can see that it's present. I'll come outside of this folder and open a terminal over here. See, now you can see I'm not inside the folder where f1.py is present. So if I try out python space f1.py, or this thing, it would say that it cannot open f1.py because it's not present in the current folder where you're running this command. So what you can say is you can either say python space this folder. Hold on. Slash, you have to use the slash on Windows f1.py. And now when I run it, it works because I have to tell that inside this folder, this file is present. All right. So these are the two ways of doing it. Another option can be you can go to cd s011, this folder, and then you say python space f1.py. All right. Cool. Another thing is when I type Python and I type F1, I don't type .py. All right. Or even if I type F, if I press tab key on my system, I just hit type F and I hit tab, it auto completes the thing. So this is a feature of these terminals that they can auto complete things by themselves. They can guess what you're trying to write over there, and then they will auto complete. All right. And if I hit it, it will just run the code. And this is one way of running the code from terminal. You can open terminal directly from here, or you can open terminal directly from here. You can go into a folder. So the command is cd space folder name. You want to come out of the folder, you can say cd space dot dot. Dot dot means one folder outside. You run it again, you go one folder outside again. You want to go into code folder, or you want to see what all folders are there, you can type dir. Then if you decide to go to folder, let's say assignment, cd assignments, and it would take you over there, cd dot dot, you come out, cd code, you go over there. All right. Try all this out on your system, and I'll give you like 5 minutes for doing all this, and let me know if you guys face any troubles or you want me to repeat. All right. And I think Dilip, Pratiksha, and Vedant, you guys would be trying out right now or no? Because
Yes, yes,
Alright.
I'm trying.
all right, cool. Just try it out.
Hi Gaurav, I am
Yeah,
able
yeah.
to
Mhm.
execute code with Notepad++,
Mhm.
but I forgot how to do with that folder and all things.
All right. So
Secondly,
okay. So with folders, it's not. I'll tell you one more thing. So this thing which I just showed you, the coming to terminal, moving inside, going out, and running something which is present inside a folder, it's not specific for Python. All right, it's common for any kind of tool that you use or that you work with when you via terminal. Any kind of tool, not just Python. All right. So if people work with Linux kind of systems, if anyone is interested in working with Linux, I'll just show you. There is a thing called as LSW or Linux subsystem for Windows. All right, and what it allows you to do is it allows you to have a Linux kind of environment directly on your Windows system, so that you don't have to install Linux or Ubuntu kind of system on your on another laptop, or maybe put dual boot on your operating system. You can work with Linux directly from your Windows system also. If you guys want to try it out, it doesn't change anything on your system. It just adds some feature. It doesn't break anything. So you can just search on Google LSW. I think I'm correct. Linux subsystem for Windows. I think it should have come up over there directly. All right, it's not showing up. So I'll say Linux on Windows. And it's good to learn a bit about Linux. I'll show you how to do that folder stuff, but before that, this I just remembered. Sorry, my bad. It's not LSW, it's WSL, Windows Subsystem for Linux. I was saying the correct full name, but uh, the reverse of this thing. I don't know why I call it LSW instead of WSL, but the name is WSL. It's Windows Subsystem for Linux. Yeah. So what you can do is you can just install and activate this thing. They give you the entire guide on how to do this on your system. And once that is done, you can later install Ubuntu distribution from the Microsoft Store. They tell you everything about it, and then you'll be able to run Ubuntu or Linux terminal directly from your Windows system. You don't need to install anything else. And then you can practice a bit about your Linux commands, and it's really fun. All right. There is a lot that you can do. mkdir, make a folder, delete a folder, how to edit files from terminal, how to use vir. There is a lot you can. That's often useful when you are actually working in organizations, because in organizations mostly people work on servers, and servers are Linux servers. Like most of the companies would use Linux servers, so it's a good thing to know. So I'll just type the name over here, Windows subsystem for Linux, and that you can try out at some point of time. Coming back to this thing, let me exit the bash shell or the Linux shell. And so see, right now I'm inside this folder code. All right, if I want to see what all files are present or what all folders are present inside this. So on Windows, the command is dir. On Linux, the command is ls. All right. So since I'm using Windows terminal right now, I'll say dir. It tells me all these folders are there. And if I say dir as this thing, it will tell me what are the files present inside this folder. So you notice this is my command dir, and when I gave it this folder name, it told me what all files are present inside this folder. So it's telling me that only one file is present. It gives some metadata about it. It says there is one file which is of 33 bytes and something else. Cool. But this is important, that it says that there is one file which is f1.py. So when you use dir command directly, it gives you the output of the current location, what all files and folders are present. If you say dir space some folder name, then it's going to tell you what all is present inside that particular folder. Cool. Same way, when you run Python, with Python, if you don't specify anything, you can see that it opens the interpreter. All right, that's the default behavior. But after the Python command, if you specify a file name f1.py, what it is going to do is it is going to find this file f1.py right where you have written Python. So it's not available there. So what I do is Python space s011, this folder name slash is the separator which is used to separate directories. If you notice, the prompt itself contains that. It's telling on D drive, the folder is data, then desktop, then this tutor, then this repository name, then code, and then I'm inside this folder. So if I have to tell Python that inside this folder, you have to go to this folder and there you will find f1.py. So I have to write it like this. Cool. Do you get the idea? But if your file is present in the current folder, then you cannot write some folder name and then say f1.py. All right. But this is the idea. Got it?
Yes.
All right. Just give it a shot. So what you can do is, maybe I think you are completely new to this kind of execution of code. So what you can do is you can just go to your this folder wherever you are putting the code. You can just create a new folder and put your file inside that folder, and that's it. You should be able to do that and work with it. All right. If you want to try out this folder option. Cool. And yeah, let me know once you're done. I'll pause for another 2 minutes and then we can continue, I guess. Anyone else, guys, any questions? And this thing is something I think you guys should try for sure. Windows subsystem for Linux, so that you can understand a bit about Linux systems as you keep using that. So that's somewhat useful. All right, done, guys. Oh,
Yes, done on terminal. Yeah.
okay. So this will, you guys might forget it, so that's fine. As you keep on doing things, you'll remember. But notice this thing. I'm using the same command Python, and it does a bunch of stuff depending on how you have written it. All right. I'll show you one another example how the same command can change its behavior. And these things which you write after a command are called as command line arguments. All right. And we will come to that specific topic of command line arguments later in terms of Python also. But if you type something like Python space -m, all right, space http.server, all right. So what it does is it runs a local file server on your system on port 80,000, or depending on what you have written, it will open there. Now, if I copy this address and put it on my system, not like this, but instead like localhost, this thing, you can see that it's showing, it's running a file server. You can see as I run this thing or as I reload this thing, new entries are getting created. So if I go inside this folder, it will show me what contents are present. It's a simple example of running a file server. Although it's not very useful right now, but you can see that instead of opening the interpreter or executing a file, it has actually started a server over here. I think this would be the first server if you have never built one or executed one using Python. The simplest way of starting any file server, a local file server on your system. It's that simple. All right. So, and to stop it, you can just press Control C. All right. Remember, there is a command called as Control C to stop things and terminate them in the middle of what they are doing. Control plus C, and you can stop the server using that command. Maybe you guys want to try this out on your system right now. So if you just try it out, notice one thing: when you start the server, it will say what port it is running. Then go to any browser that you have on your system and just type localhost colons 8000, and it will show you the directory listing for that particular folder. But don't keep the server running. It might cause some issues later, but this is one thing. Maybe give it a shot right now, running this local file server. And this localhost 8000 will work only on the laptop where you have run this server. It won't work on, like, you run this server on your machine and then go to some other laptop and type localhost 8000. It won't show you, because if you are not aware, this thing is very new for you, then localhost means your computer's local servers. It cannot access some other machine's servers. For example, I showed you that this Jupyter Notebook is running on a server, which is not my local system, but I'm able to access it because I've done the proper setup and pointed my domain to this particular server so that I can access it from anywhere. Just like how you open this website or any website, I have done some setup for that to work. But when you run this local server, this is not configured to do anything apart from running things locally. And I think I'll make some content about how some tools, probably I'll share it across to you guys later. But these things are interesting, actually. Did you guys try this out? So the command is python-m space http.server, and it just runs a server. Your first server maybe. Works. If you said something, I'm not able to hear anything.
Just feedback I'm done.
Your voice is breaking like a lot. I didn't make anything out. All right, I'll just assume you guys are done with this thing, and you guys are getting this as well. But these things are fun and useful. All right, so now let's come back to Python stuff. You're done. Cool. Great. So what
Yes, I
next?
am able to do. Yeah.
All right. You. So what were we talking about? We were talking about running code from your terminal and using Notepad++. So that should be clear to you guys now. And what else about this thing? So this is one case. So let's say I write hello from, let's say, my name. All right. Now I go to the terminal again. So this time I'll open it from here, open containing folder in CMD. And this thing opens a terminal directly where this file is present. Now I can say python space f1.py, but it doesn't show me my name. It shows the old code, hello from Python script. The reason is I didn't save the code. You can see that the file is showing red. Once I save this thing, I hit Control S, it got saved. Now after saving is, if I run this thing, now you can see that it is reflecting the change that I did. So sometimes we write the code and we forget to change it. All right, so be aware of that. Cool. Some of these tools, or sometimes these tools have autosave enabled, just like your Jupyter Notebook has. So you can see that it's autosaved, but still, if I just type something over here, let's say 1, 2, 3, it says unsaved changes, and then it all of a sudden turn to auto save. All right, so it keeps on auto saving. Same features are available in these kind of things also. You can probably go to your preferences or settings of this particular tool, and there will be a bunch of options, and from those options you can turn or auto save on or off, enable or disable them. There are a lot of things over here, so I don't know where auto save is. Enable, probably somewhere it would be. All right, but these kind of options are also supported by these tools. So this is example of your Notepad++. Oh, cool. Now if I have to go to Pycharm, I have this community edition installed. I don't know if I ever ran this tool on my system, but not sure. Yeah, I think I'm running it for the first time. So it's asking me to accept the license also. I don't want to send data, so shut it down. So this tool is somewhat heavier. It might take a bit to load on your system, but you can also install this software and you can use it to write Python. There will be a difference between that versus this Notepad versus this thing. So I'll just go and say, let's say open. And the same way that I did for my, is there a short option for going to desktop? Is there a desktop over here? No, so I'll need to go to the data, desktop. There's desktop over here, and you can see that as I keep adding folders, it adds ///, just like how we were doing on command line when I was running Python space that folder name slash thing. So if there are multiple folders, you can say Python space folder 1 / folder 2 / folder 3 / name of file.py. So like that, it can work on this thing. So I'll go to this Tutort folder and I'll select this folder and I'll click on OK. And this opens a new window with that particular workspace. And I think it closed the old window automatically. You can see it's saying preparing workspace. So workspace typically means a folder or a structure where your code is there. So if you notice over there, it will, I think it's still loading stuff. So I'll let it load things. And I don't know the C tips right now. So I'll close this thing. And you can see that it's even able to load the README for me automatically in the Pycharm itself. I don't, because if I go and open the README inside this Notepad++, it will look like this. This is markdown syntax. All right. And whereas this Pycharm shows it to me just like how it appears on GitHub. So these kind of IDEs or integrated development environments are much more powerful than your simple plain text editors. And they're literally very useful. So if I go to this code and I open this folder and I open this file f1.py, and to run this thing, so I'll just need to go to, let's say, run, and the shortcut is Alt Shift F10. So you can remember the shortcuts. And let's go to edit configuration because it doesn't know where my hold on, why does it ask for configurations? I think it should be able to run it directly. Okay, maybe this thing doesn't know how to or where my system's Python interpreter is. No, it does know where my interpreter is. So You can run the interpreter also directly here. I don't know why it didn't run the code in my case right now. It should have ideally run the code directly. Why does it say edit configuration? Did it print hello world anywhere? I don't see that. There's a problem. I don't know where the code is going or where the execution is happening. So I think I'll need to configure the settings for your Python or the. Can we use Visual Studio as well? Yes, you can use Visual Studio. I also use Visual Studio for this thing. Both things work. All right, but Pycharm is specifically tailored for what Python. If you are someone who wants to work with multiple programming languages, I would recommend using Visual Studio. All right, instead I use Visual Studio Code instead of Visual Studio, because a lot of times what I do is I don't run code locally on my system. I have to run code on a remote server, and Visual Studio Code allows you to run and work with code stored on remote servers, not just on local servers. So I prefer to use this Visual Studio Code for me instead of using let's say this instead of Visual Studio, I use Visual Studio Code because a lot of times my code is not present on my system, it's present on a remote server, hence I use that. All right, so in case of this thing, we go to add configuration and let's say no run configurations added. So I'll just go and say in Python, and then once let's say Python over here, let's call it Python, and for this thing I can set what all settings are there for this Python environment and what all it should do. So I can add some settings for it, and it has detected which Python interpreter to use. So you can see it has picked the Python interpreter for me from the Anaconda installation itself. So I'll just go and say apply and click on OK. And now if I go and probably run this code, this Alt Shift and F10, because this zoom pop-up just keeps on coming on pop. I think it should be able to run with 10. As it is already available with Anaconda. Yeah, Spider is also a decent thing, but I haven't seen anyone using Spider till now. I've never seen that. I have used that sometimes, probably because earlier in the sessions, just once or twice, because I was not doing this thing. I was not using Pycharm then, or I was not having any IDE installed on my system, but now I have IDE installed on my system, so I prefer to use an IDE, or mostly I use Notepad++, but feel free to use Spider also. If you just type Spider over here, so it is something similar to your Pycharm, but it's a different kind of tool, different from Pycharm, but it's also an IDE. All right. What went wrong over here? Did it not run the code? That's bad. I don't know why this thing is not running. This should not happen. Let's come to Spider.
Because the local system was having issue, right? We had Jupyter Notebook version not working.
Sorry, I couldn't get that.
Is it because your Jupyter Notebook was also not working? That using some kernel not?
Oh, maybe correct, because my Jupyter Notebook's kernel, maybe some Python issue. I think there is some issue with Python, but since the normal just the Python is working on my system, let's see which Python it is using. It's using the same Python, which is in Anaconda folder, but I think there's some issue with my Python setup. Probably that's why it's not able to run. But if you guys want to try it out on your system, feel free to try out. Unfortunately, right now, I'm not able to show you what's happening. but you can access the advantage of IDEs is that you can do a lot of things from this same interface. You don't have to jump between things. For example, I don't need to go to Notepad++, then go to terminal and then run the code. And I can open a terminal right within this window itself. And you can learn the shortcuts to jump from here to here to here and all that. You don't even need to touch your touchpad. Now I can say Python space code slash your s1011 slash f1.py. I can at least do this and it runs. I'm not sure why it's not able to run it directly. Maybe I need to fix my run configuration and it will work. Let's just stop this thing. Let's close this thing. Let's disconnect, or let's say terminate from that process. Terminate that process. Let's give it another shot. Let's say run. Why is it running Python? I'm not sure. It shouldn't be doing that. Say terminate. I think I need to fix the run configuration for that. Then it will start working. Even this spider is broken. So sorry guys, I cannot help with these tools today. I'll need to reinstall Anaconda. But the idea is learn to how to use IDE, because most of the people will be using IDE. And Jupyter Notebooks is also something everyone uses. So learn two things: an IDE, a Jupyter Notebook. Anyways, we are going to use this Notepad++ throughout the sessions. And why I use Notepad++ and not an IDE during the sessions, there is a specific reason for that. For example, if I say print, okay, so this is not doing an autocomplete over here. So typically what would happen is your IDEs provide you an option of autocomplete that works very nicely. All right. And because that autocomplete is not working over here, it's not giving me some kind of suggestions. But what typically autocomplete would do is it would allow you to see the help about this thing. It would allow you to jump to the documentation of this thing. It would allow you to autocomplete. For example, once you type some name print, it will give you some suggestions what all you can use over there. For example, it shows me some suggestions over here. I think it has not properly indexed. That might also be a reason, but you can just use this autocomplete feature, which is not available in your simple text editors. And for the initial learning phase, using simple text editors can be good. Why? Because you start remembering the syntax of the programming language. All right. Otherwise, if you just keep using the IDE, because of autocomplete feature, sometimes you don't get to remember the syntax. So initially in learning phase, prefer to use a text editor. Once you are working, while working, always use an IDE or some kind of tool, because it makes or saves your time a lot. Cool. So this is the idea. Do you guys want to try out the same thing on your Pycharm? If you have installed, just take 2 minutes to try it out. Or have you guys installed Pycharm by the time I was talking? No? Yes? Okay, installed. Do you even want to give it a shot? Okay, what did you try? Facing the same issue. I have never used Python in work also. I mostly use Jupyter Notebook or Visual Studio Code. All right. And for Visual Studio Code also, there is a different version, which is Insider's build. So if you want to do remote work on a remote machine, you have to use Insider's build, not the normal Visual Studio. So you can try that out later. So with Pycharm, we'll have to see how to run this thing. Maybe I'll give it a shot right now. Let's say edit configurations. So there is one configuration Python. Let's see, edit configuration templates. So there is compound something. There is Python. What does Python have to say? Environment variable, interpreter, and interpreter options. I don't want to give any options over there. All right, I don't know how to fix this thing, but cool, we can figure that out later. No issues with that. This is something which we'll be able to easily do it if we maybe find online. It won't take that much session. You can see there are a lot of options inside IDEs, so they are good, but use them for work. For learning purpose, try to use mostly editor and a terminal for doing that. Cool. So that's the idea about these things. Now coming back, so you guys should try out some commands on the terminal and all the stuff. And this is pretty much about this kind of thing. What we'll do is, I think for today, mostly we are done. If you guys have any questions, let me know, because from tomorrow we'll start with Python code exactly and learn about things. And I will specifically be focusing in terms of memory that we learned yesterday and something about variable kind of things tomorrow. But yeah, that's the idea in terms of what we are going to do. And then we'll jump to this thing from probably Saturday onwards. But tomorrow we are going to talk in terms of variables and Python's memory allocation and data types of it. All right. For today, mostly, I think we are done about these things. Ask me any kind of questions that you have, guys. Let me know. Anything. I'll wait for 2 minutes. Probably try out some tools, or let me know if you want me to show something else. I forgot to talk about this today, so we'll definitely talk about this. But this comes in context of more of Python, the code itself, so we'll talk about it later anyway. So let me know, guys, if you have any questions. Otherwise, I think we'll drop off 5 minutes early today. That's good. Typically, we mostly drop off later, but today is a good day. So yeah. Anything you want me to explain again? Did you guys get everything today that we talked about? And let me know of any questions. Otherwise, I think we can drop off, and I think we are all at it. Okay, we did Python HTTP. What is the exact use of it? I don't know what is the exact use of it. Sometimes what I do is, I just typically use this to sometimes check whether, how should I say, I use it for testing purpose, that whether my system is working fine or think something is working fine or not. When I say something, what I mean exactly is, I'll show you. This is it. Then does this work? Yeah, this thing worked. All right. So I'll just run python-m http.server. All right. So it says that it is running on a particular port. Now, if I want to use or access this thing, all right, and what I do is typically when you're running a server or a machine, that machine has a notion of ports. Ports are something like numbers on which that it checks what requests are coming from the outside world. So it is running on the port number 8000. So sometimes those ports are blocked. Blocked in the sense, if any request comes in, it will not reach your server because your network layer, the part through which your request come to your server or reach your server, they block it. So you have to go and open these ports in your server. All right. So what I typically do is I just open the port and I just run this Python server file server, and I go to the IP address of my server, type 8000. You can see that the IP address right now it shows is 0.0.0. I just go and say 8000 with the IP address. 0.0 is a kind of your local host IP address or loopback kind of IP address. So I put the IP address, put the port 8000 and see if I'm able to access files. If I'm able to access files, it means that port is open for incoming request. Otherwise, it is blocked. If it is blocked, I need to go and fix the configuration of the server to see if the port is like make it open, and then I try it again. So that's why I typically use this thing, python-http.server. Sometimes what I also do is you can do something like this. If you are if I'm building a small website kind of thing, just a temporary dummy website. For example, I go over here and I just say control N. Let's say, how do you write this? Head / head, and let's save it as HTML. What's happening? If I go and say, why is it not? I don't know why, but it's just not allowing me to edit this file name. That's weird. Too many weird things happening today. Okay, now I get it. I think that's because Pycharm is holding probably a lock on that folder. Let's close Pycharm. Sometimes weird things happen between different tools. I'm able to edit here. If I go outside. Okay, so there's some issue over there. Let's say there's some issue with this Notepad version maybe because its state is messed up. It was not an issue with Pycharm. Let's say index.html and let's go to the outside folder and save it there. It's literally very bad. I'm not able to do it. So some issue with this software. Normal text file. And let's say slash okay, we don't even need a head over here. We can just say body and slash body, and we can put, let's say, hello world, and this is saved inside that same folder, and I can just exit here. I don't need this thing. Let's close this thing. Let's open the folder over here. Open containing folder in CMD again, and Python -m http.server, and now I can go there and do my browser, and I can go to that local host 8000, and it just displays the index.html page. So it sometimes use it to make some local website or something. Rarely I use it, but now you can see it doesn't show the file structure. It automatically loads the index.html file and serves it via this server. So it's like a normal HTTP server. If you have HTML files, it will run or serve those HTML files. So index.html is a special file. If you put that over there, so it's the default file that is loaded for your at the slash or the root of your system. All right. So if I just put this index.html over there, so it loads up the index.html. So sometimes I use it for that purpose also. Got the idea somewhat? So it's file server and it can do some other things also. Cool. Any other questions you guys have? These are just tools that you gradually learn as you start working. Fine. All right, guys. So then anything else?
I have a question about our class tomorrow.
Yeah.
Yeah, so tomorrow, is it going to be on programming or are you going to go through some other topics?
So today I was thinking we'll go with programming, but I wanted to talk about other things. So tomorrow it will definitely be about code. Yeah. So
Then how about the weekend?
on the weekend also it's going to be about code. So we'll start
Okay.
writing code and understanding Python from tomorrow onwards.
Okay.
Yeah. So tomorrow will be like a very basic stuff that will start with the complete basic of Python and how things relate together. And from the weekend onwards, we'll continue from there, whatever we are able to do tomorrow. We will continue from there itself, and then we'll keep going deeper and deeper into Python with the applications of things. Yeah. Is there something specific like you wanted to ask, like in terms of what we are doing tomorrow, or like from a
Maybe I just want to understand like what's the schedule like.
okay, all right. So schedule in the terms of topics, I'll be able to give you a rough overview of how the topics are going to come. Do you want that, or is it something, for example, when I say topics, so the schedule would be in terms of which Python topic we are going to roughly cover when. All right. Is that what you want to understand, or is it something like when we are doing Python, when we are not doing Python, something like that?
Yeah, I think I just want to know, right? I mean, for my understanding is that on
Mhm.
the weekdays, usually we are doing more on the concept and basics, right? And
Uh-huh.
during the weekend, we will do more on the coding.
Uh-huh.
That was my understanding. Yeah, because
Okay.
some of the
Mhm.
some of the weekdays I might have to skip the live class and go for the recording instead. So
All right.
I don't want to miss out the important things.
Okay. So
Mhm.
I think tomorrow will be our only weekday class right now. Like after that, we won't be having weekday classes. We'll mostly have weekend classes. Probably
Oh,
for some
okay.
special sessions, we'll have a weekday class. Otherwise, we won't have weekday classes. So don't worry
Oh,
about that.
okay.
Yeah.
Okay.
And because tomorrow we'll somewhat start with a bit of Python and understand some basics. After that, our next sessions, which will be on weekdays, which will also be on Python, it won't be like we are just covering things. It will be like you'll get a complete understanding of what concept we are talking about, and
Mhm.
it won't be it won't be assumed that you already know Python or programming. It would go in a sequential manner, like once we learn about the basic, then building on top of it, then building on top of it, on top of it, like that. It won't be an
Mm,
assumption like you know something. Does that help?
okay, sure. Yeah. Thank
Yeah.
you.
Yeah, because even when you learn about any new concept, because Python has a lot of concepts. So when you learn about a new concept, it will be new. There's it won't be like you can already know about it. If we talk about functions, functions
Mm,
is a concept. So you'll have to learn the basics of
mm,
functions, then a medium level of functions, then an advanced level of functions. So it will go like that. So
right. And when you mention
mhm,
weekend, the classes is on both Saturday, Sunday, right?
correct.
How many?
Yeah,
Yeah, okay.
exactly.
And
Yeah.
the time would be what time again? I cannot remember.
So the time in terms of
If
IST would be 9 to plus 3 or plus 3.5 hours. So 9 to
okay.
roughly 12. All right. And on what is 9 to 12? Okay, it's because of COVID, it's giving this thing. So
Yeah,
school
it's
reopened date, but so
11.
it's going to be 9 to 12. And
Okay.
probably we'll have a break in between. So it might go somewhere around 9 to 12:15 or something like that.
Okay.
12:20. All
Okay.
right. Does that work?
Okay. Yep. That works well for
And
me.
on Sunday, probably we'll have to move our class a little bit early. Maybe I'll discuss with Abhishek. Probably we'll start at 8:30, maybe, or
Mm,
something, because on Sundays I have another session which was already fixed around 2 months back. So till the time that doesn't end, that session starts from 11 a.m. So I won't be able to
yeah.
take beyond 11 a.m. or till 12 on those days. So we'll figure it out. But yeah, that's the overall rough schedule. Cool.
Okay,
I'll put
sure.
it out on the this thing. Say weekends. Say what 9 to 12 is the actual time, but we'll see on Saturday, Sunday what we can do. I'll discuss with Abhishek and let you guys know. On weekdays, don't worry about it. Tomorrow is going to be the last class. Initially, I thought like we'll have a lot of very basic stuff that we'll be learning about programming in general, but I think we did quite a lot, yes, in one day itself yesterday. So, and that's what
Mm,
is relevant for learning Python. Initially, I was thinking it will be a lot, but now I think we'll be able to do it fine. Because otherwise we would have had maybe two more. So we are right now having three
mm,
sessions, yesterday, today, and day after tomorrow, like tomorrow. Otherwise, we would have added two more sessions maybe next week, but I think we don't need them right now because we are already pretty much done with it. There is a concept of arrays, which I already told will come later, but I'll talk about it when we reach that point in terms of Python itself, because otherwise there's no point of it. You'll forget by the time we reach to arrays in Python. So we'll take it up over there. All right. So a bit of change in order for that. Cool.
yep,
Anything else, guys?
thanks.
Yeah, no worries. Thank you. What else, guys?